Alrighty, so what I've got, as you can see, is space exercise for this video. I'm Ryan Meitiger, as you know. This is the treadmill they use that, if you've ever had Randy, he probably explained that when he was at Kennedy, he actually was one of the people to test that. It was pretty cool. And then this is one of the strength conditioning kind of things that they use. I'll explain that a lot later. So the main topics that NASA focuses on are the cardiovascular, pulmonary, bone, muscle, and sensory motor, because these are disturbed in many different ways when you go into space and you don't have as much pressure on you. These are just some definitions. So like the ARED, that's the exercise equipment that I was saying, we'll explain later. The IRED is a earlier version of that. Deconditioning is essentially you just lose a stimulus so that or you lose a stimulus, so you have to adapt to that, so you essentially decrease your strength. Sensory motor disturbance is just loss of locomotor abilities, so you're walking, your perception of where you are and stuff like that as well. The G-force, or gravity, on the Earth is 9.81 meters per second. There's 86,400 seconds in a day. And so in 1 second, a 100 kilogram person will have 981 meters newtons put on them. And so throughout the day, cumulatively, the person would have 84,758,400 newtons of force put on them cumulatively throughout the day. So in the space station, near the vacuum of space, there's essentially none. It's completely gone. On Mars is about 37% of Earth's gravity. There's 31,360,608 newtons put on the person's body. A little bit of background: we've always been exploring. We've always been looking for new places to find out something new about. We've gone to the Americas, we've gone to different places over in Asia and Europe, in different islands around the world, and now we've also gone to space. We went to the moon, we're trying to go to Mars now. We might possibly try to go to Pluto or possible moons of Saturn as well, because they might have water on them. We put drones on asteroids. We've looked deeper and deeper into space with the Hubble telescope, and we've done so many more things with space exploration. So the main purpose of this is to show the stresses of going to space on our bodies, and essentially what we lose when we go to space and what we can do to fix that possibly. And then possible ways to improve how we can exercise in space and maintain our bodies. So I'm going to break that down between the main points that we were talking about earlier. So on Earth, cardiovascular, we maintain that by doing endurance training. You can increase your muscle size both in your heart and on your whole body with that, and then increase other things as well. And I will talk about the ACSM position stand a little bit later with the bone health, but that's something to always look at to recommend things like that. In space, here's that treadmill again. We have deconditioning. We have fluids moving up towards the head because there's no gravitational pull pulling them down towards the feet. That's a decrease in that stressor on the body. That causes an atrophy of the cardiovascular muscles. And then there's this treadmill, as I said earlier, and then they also actually have a VO2 max test where it's kind of an upright bike. I have a picture of that a little bit later. So I found a couple of articles that showed like decreases in the cardiovascular function in space. So we have fluid loss, we have decreases in blood pressure, we have a decrease in stroke volume, we have a decrease in the baroreceptors of the carotid arteries picking up signals, and then most of the time we'll notice those things upon re-entry, and it's pretty sudden. Some of the people can't even walk when they come off of flying. And the article I found showed that you could possibly do this twin bike system where there's two astronauts in a centrifuge biking together, and it essentially uses a centrifugal force to push them outwards or pull them outwards, creating a gravity type environment. It was really cool concept, and I hope that they use it because it could really improve space flight and living in space in general. So then I found another article that showed a decrease in endothelial dependent functions. So that's again back to the baroreceptors, reflexes to different things within the blood, stuff like that as well. And then the big thing that they found too was there was some of these endothelial tissues coming off even more than they normally do. Usually there's probably a little bit of it in the blood, but it's increasing as people are doing bed rest and in space. So now on pulmonary on Earth, there's aerobic effects from endurance exercise, but it's not to the extent of cardiovascular or the other effects either. There's really no breathing techniques that change this. We can increase capillaries, it can increase the transfer of oxygen and carbon dioxide to and from the blood, but really not too much. Here's that VO2 max machine. If he would turn around on here, there's a tube that's essentially just like the VO2 max machine that we have here. He can breathe into while he's running upright, kind of in a cycling form. It's really cool. So a couple of the things in space that we have to worry about for the pulmonary function is that thermoregulation is very difficult in space. It's hard to increase temperature and decrease and not let that get out of control in the human body in space. There's a lot of different things, whether it's the fluid loss or decrease in blood pump or anything like that, that's actually affecting that. And then there's also the carotid artery baroreceptor issues as well. So how do we fix that? We don't really know yet. I couldn't really find too much information on that. There's possible, if we continue to work with exercise and research it, that's a possible thing. So it could be a thesis or a dissertation for somebody in the future. It's an idea. So on to bone health on Earth. So this is part of the ACSM position stand for bone health. And so you do a high impact, high intensity on the bone load, and then you do this 3 days a week for 10 to 20 minutes or 30 to 60 minutes a week. And then for adults, you'll do weight bearing 2 to 3 times per week of resistance training, 3 to 5 times a week of endurance training, and then it's to a moderate to high intensity. And obviously you'll have more and more benefits as you increase your intensity. There was some stuff as well in the position stand that said that you could combine these two things together. It's kind of like in John's article where we talked about how the short sprints over a certain period of time work on the oxidative system as well. And then so if you can do that in lifting or in other things too, it's just another variation technique essentially. So in space, we'll go on to talking about the ARED because this is the big thing that's used to increase bone health in space and also muscle health because they can load that up to 600 pounds. It's crazy how much they can do. I think the IRED was like 300 and some pounds. It really wasn't very much. So they weren't really loading themselves too much, whereas some people might still think that 600 pounds is a lot. It's really not too crazy. But anyway, the frequency and duration that these people are exercising in space, the astronauts, cosmonauts, and all the different ones, they're exercising 3 hours a day every single day, which is, it might not seem like too much, but when these people need to be researching as much as they possibly can, that's actually quite a bit. So with the ARED, there's a ton of different lifts that are simulated. They have this vest that they can hook people up to, or they can do like jumping things, they can do calf raises, they can do, they have a bar to hook up that they can do squats, deadlifts, overhead presses, bench presses, anything, any presses or anything like that they can do. And then they also have a cable set up as well. And so as they're doing their exercise, the machine's actually also calculating and measuring all of these different things. There's force plates within the ARED system, and there's all types of measures being shown to show their progress, their changes, any decreases they might have in anything, because that could show something that either they need to work on or something that maybe they're having a problem with or something like that. So that then is used for their exercise prescription in the future so that they can go on from there and be much better. So another article here is, it showed the mechanical stimulation to recovery from space flight or bed rest. Essentially it's just if high magnitude, low frequency, so like loading up a bunch of weight and doing a small amount of reps would be an example of that, or low magnitude, high frequency, where it would be like doing a bunch of reps over a certain amount of time, would be the best way to go about this. And they didn't do like the weight training or anything like that. The low magnitude was actually just doing a postural control exercise, they called it, but it was actually just standing in place for 3 hours. And that loaded the body enough to actually increase bone mass and strength. So it was a cool little article, and they showed that that might actually be even more effective. Not quite sure. I mean, you can take that any way you'd like on that one. So on Earth, we go back to the position stand again for the exercise recommendations, but the adaptations we have during those things are hypertrophy and strength, and those are two main components that are lost for muscle in space as well, and so those are big things that they're trying to fix. So the ways that they do that is they do the ARED system, they train on that, and then they also do cardiovascular training on that treadmill we had talked about, and then bikes, stuff like that. And then as I had said earlier, 3 hours a day, every single day. So then there is sensory motor disturbances that happen, which is essentially locomotion. So just walking from one place to another is an issue. They lose, or we have control of our movements. We have skills that we learn over our lifetime, and we have what people call muscle memory, or just motor neuron efficiency over time. And so that is something that we have on Earth that we kind of take advantage of every day. But in space, we lose that. We don't have the stress of being, on the ground, moving or running or anything like that. And on average, they're in flight 185 days. And there's there's two people right now, a guy from Russia and a guy from America, who are doing a year-long journey. So a year of literally just floating. They don't have to sense where they are, where their limbs are, or anything like that. They're just floating there. So they're losing all these sensory motor abilities. They are, the changes that are really big that are happening is they're losing their perception. So obviously, perceiving how they're moving, stuff like that, and then their spatial orientation. So essentially, like, they might run into walls right after the time that they've been in space because they have no clue how close they are to that, because they're used to floating up to a wall, and they're not feeling that at all. And then they'll lose posture because they're not standing. Now this might be improved using the ARED and using the treadmill, but still at the same time, like the picture the treadmill showed, it's only hooked to the hips. It's not hooked to the shoulders, so having to hold yourself up is an issue still when they come back. So if often these people, you might have seen it before, are taken off of the space shuttle on wheelchairs because they just can't stand anymore. This also affects their gait and eye-hand coordination as well. So not having to walk, you lose the thought of needing to be able to do that. You lose the efficiency of being able to do that because you're not doing it anymore. And that's improved a little bit with using the treadmills and stuff like that, and then also possibly doing the cable things to increase hand-eye coordination or anything like that. But it's really not to the extent that we need it to be yet. So those are some big changes and losses there. So the study that I found with that showed when they need to start testing and relearning all these things. And so they tested the astronauts coming off and people coming out of bed rest with a head down tilt. They do a 6% decrease in the grade, and they showed that when they would just walk around obstacles, they were actually having an issue with that. That's the spatial awareness and perception of things, and also gait being disturbed when they're coming back from space. And so when they tested these people, they showed the issue, and then they had to figure out when they need to start retraining these people, because along with muscle loss and stuff like that, some of these things are never regained. Some of the things that they went up with, the strength and stuff like that, it's never regained. And so they wanted to decrease the loss of sensory motor disturbances. And so they actually did tests right away, and then a couple of different increments after that, and they showed that right away was obviously the big improvement. They actually got back most of their movements, if not all of their movements, and they were almost perfectly fine very quickly. So that goes back to the adaptation to gravity, essentially, or 1G, because not having that stress, you're going to have to also learn new movements, new spatial awareness, new ways to move your arms, ways to locomote essentially. Ways to move around in the space station are completely different than ways on Earth to move around. And so the take-home message for this is that right now it's not very efficient. The 3 hours is a long time to do every single day, 3 hours of training. So what are some ways we can improve that? So we've got the ARED is a good start at least. And then there's the treadmills and the VO2 max machines that can be used for the testing and training and stuff like that. So we need to use those, but somehow we need to make those more efficient. For the treadmill, possibly finding a way to incorporate the upper body, I feel, as well into the movements of the lower body, so it's not only the lower body moving, would be a big improvement upon that, but that would also be difficult too, because that would be possibly pulling them forward or pulling them back, so there would have to be pretty substantial study on how to make that the most effective way. Possibly using electrostimulation, because they have a percutaneous muscle stimulation unit actually on the space station right now. And electrostimulation has been growing a lot in the strength training field and showing that it has a lot of promise. It can possibly increase things like in tennis players, it can increase their muscle strength and stuff like that too. And it's been used for a long time in athletic training, personal or physical therapy, a lot of those different things. So I think we need to study it more and find a way to get that applied to using it in space. And then another thing too, that it's been researched recently as well, is vibration technology. The ARED equipment actually has the ability to incorporate vibration into the strength training. So I think that would be another thing to add in. Maybe even if they had to do that a couple of times a week, if we can cut an hour off of that exercise, it's a huge change. And that would be an hour that they can be, testing the new food that they've been able to grow up in space, or increasing all the research that they're doing up there. Because right now they're losing an hour, I feel, or they're losing up to maybe an hour and a half. So if we can find better ways to stimulate their movements to be more like Earth, or create gravity, maybe with that twin bike system, to be able to create gravity, they could bike in the centrifuge to stimulate their body in the way that they're used to and their body is used to as well. And that's it.